quiz covers just section 2.5, but it's all 3 parts of it. Okay, so it's 6 questions, not hard. If you know what you're doing, you'll be fine. For number 1, you are solving the equation by factoring. You have 4x to the 4th power minus 16x squared. You do have a greatest common factor with these 2 terms. The greatest common factor is 4x squared. So we factor that out first to give us 4x squared times x squared minus 4 is equal to 0. Your x squared minus 4 is not factored completely. So you could either factor it further, or you could just set it equal to 0 and then solve. If you set it equal to 0 and solve, you're going to have 4x squared is equal to 0, as well as x squared minus 4 is equal to 0. For the 4x squared is equal to 0, you're going to divide each side by the 4, and you have that x squared is equal to 0. And then take the square root of both sides. 0 is neither positive nor negative, so x is just equal to 0. For the x squared minus 4 is equal to 0, add your 4 over. You have x squared is equal to 4. Then take your square root of both sides, and that's going to give you x is equal to plus or minus 2. So you have 0, negative 2, and positive 2 for this one. For number 2, you have x to the 4th power minus 5x squared minus 36 is equal to 0. For this one, you have an x to the 4th power, not an x squared. Just like you have an x squared, not an x. So keep that in mind while you're factoring this. Your a is 1, so find your factors of negative 36 that add up to be negative 5. That's going to give you 4 and negative 9. So this factors to be x squared plus 4 times x squared minus 9 is equal to 0. You can set these both equal to 0 and solve, or you can factor out that x squared minus 9. Up to you. I'm going to set them both equal to 0 and solve. So I'm going to have x squared plus 4 is equal to 0, and x squared minus 9 is equal to 0. We're going to move the 4 over by subtracting it from both sides. So that's x squared is equal to negative 4. Then we take the square root of both sides. So we have that x is equal to plus or minus 2i. Remember that I, because the negative that's underneath that square root. For the other one, you're going to move your 9 over by adding it to both sides. That's going to give you x squared is equal to 9. Then you take the square root of both sides. So you have that x is equal to plus or minus 3. For number 3, you have 5x cubed plus 30x squared plus 45x is equal to 0. You have a greatest common factor between these 3 terms, which is 5x. So we're going to factor that out first. We'll have 5x times x squared plus 6x plus 9 is equal to 0. This x squared plus 6x plus 9 is a perfect square trinomial. So this factors to give you 5x times x plus 3 squared is equal to 0. You're going to set both parts equal to 0 and solve them. So that's 5x is equal to 0, and x plus 3 squared is equal to 0. For the one on the left, divide each side by the 5, and you have that x is equal to 0. For the one on the right, take the square root of both sides. You get x plus 3 is equal to 0. And then move your 3 over so that you have that x is equal to negative 3. Your next section, you are solving the equations by taking the square roots. For number 4, you have 3 square root x minus 6 is equal to 0. First thing we're going to do is isolate that square root. So that 6 we're going to move over by adding it to both sides. That gives us 3 square root x is equal to 6. Then we divide each side by the 3. And we have that the square root of x is equal to 2. From here, in order to get rid of that square root, we're going to square both sides. So that's going to give us x is equal to 4. For number 5, you have the square root of 2x plus 5 plus 3 is equal to 0. For this one, we're going to move the 3 over, so we're going to subtract it from both sides. This gives you the square root of 2x plus 5 is equal to negative 3. before you keep going with this, that 3 that's on the right side is negative, and there is absolutely no way that you can take the square root of any number and get a negative number. So because that's negative, this is no solution. For number 6, you have the square root of x plus 1 minus 3x is equal to 1. So for this one, we are going to move the 3x over first. So we'll add it to both sides. This gives us the square root of x plus 1 is equal to 3x plus 1. From here, we're going to square both sides so that we're working with x plus 1 is equal to 3x plus 1 times 3x plus 1. So we're going to FOIL out the 3x plus 1 squared. That's going to give us x plus 1 is equal to 9x squared plus 6x plus 1. I have an x squared, so I want to move the x and the 1 over to the other side. So I'm going to subtract x from both sides. I'm going to subtract 1 from both sides. This is going to leave me with 9x squared plus 5x is equal to 0. From here, factor out your greatest common factor, which is x.
I was in guidance.
You're fine. So that's going to give you x times 9x plus 5 is equal to 0. So that's x is equal to 0 and 9x plus 5 is equal to 0. The x is equal to 0, that's an answer. Your 5 in the 9x plus 5 is equal to 0. You're going to subtract over to get 9x is equal to negative 5. And then you're going to divide each side by the 9 to get that x is negative 5 over 9. For number 7, you have the square root of x plus 5 is equal to the square root of 2x minus 5. For this one, we're going to start it by squaring both sides. That will get rid of your radicals to where you're just working with x plus 5 is equal to 2x minus 5. Move your x over by subtracting it from both sides. You're going to have 5 is equal to 2x minus 5. Then add your 5 over. This is not 2x, this is just x, I'm sorry. X minus 5, there we go. From here, you're going to add your 5 over. So you get that x is equal to 10. For number 8, you are solving the equation by eliminating fractions and checking for extraneous solutions. You have 1 over x minus 1 over x plus 1 is equal to 3. For this one, your least common denominator is x times x plus 1. I'm going to multiply everything by our least common denominator. So that means that we are going to have x times x plus 1 times 1 over x. I'm going to move that negative up to the 1 so that I have a positive x times x plus 1 times 1 over x plus 1 is equal to 3 times x plus 1. So canceling out our like terms, the x's cancel out, the x plus 1 cancels out. You're just going to do 1 times x plus 1 plus x times negative 1, because this one was negative.
How are you able to change the sign between the numbers?
We can change the sign by just keeping it with the term that it's attached to. So I just keep it with the 1 that's up top, and then it becomes a plus sign between the two fractions. So I do that just that way I remember that negative. Because if not, then I'm going to have to apply it to my least common denominator, and sometimes that changes the value of your least common denominator. So I just keep it with the numerator of that fraction that it's in front of, and change the sign between the two fractions to be positive. So from here, on the other side of that equal sign, you're going to have 3x times x plus 1. So you are going to multiply this out. That's going to give you x plus 1 minus x is equal to 3x squared plus 3x. Combine your like terms on the left side. Your x's are opposites, so they cancel. You have 1 is equal to 3x squared plus 3x. We're going to move that 1 over by subtracting it from both sides. So that's going to give you 3x squared plus 3x minus 1 is equal to 0. From here, we're going to try to factor this. Your a is not 1, so if you multiply 3 times negative 1, that gives you negative 3. Your factors of negative 3 that add to be 3 are none. So you're going to use your quadratic formula in order to solve this. Your a is 3, b is 3, c is negative 1. So if you remember your quadratic formula, it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to give us x is equal to the opposite of 3 plus or minus the square root of 3 squared minus 4 times 3 times negative 1 all over 2 times 3. This is going to simplify to give you negative 3 plus or minus the square root of 9 plus 12 all over 6. The 9 plus 12 add to give you x is equal to negative 3 plus or minus the square root of 21 all over 6. That square root of 21 does not simplify, so that is your answer. For number 9, we have 4 over x plus 1 minus 3 over x plus 2 is equal to 1. For this one, your least common denominator is x plus 1 times x plus 2. From the start, I'm going to move that negative up with the 3. So I just turn it into addition, move the negative up with the 3. That 3 becomes negative 3. From here, I'm going to multiply everything by my least common denominator. So x plus 1 times x plus 2. This means I'm going to have x plus 1 times x plus 2 times 4 over x plus 1 plus x plus 1 times x plus 2 times negative 3 over x plus 2 is equal to 1 times x plus 1 times x plus 2. So from here, I'm going to simplify. The x plus 1's here, simplify. The x plus 2's here, simplify. So ultimately, I'm doing 4 times x plus 2 minus 3 times x plus 1 is equal to x plus 1 times x plus 2. I'm distributing the 4 and the negative 3. So it's going to give us 4x plus 8 minus 3x minus 3 is equal to that x plus 1 times x plus 2 FOILed out is x squared plus 3x plus 2. I'm going to combine my like terms on the left. The 4x minus 3x is x. The 8 minus 3 is 5. And this is equal to x squared plus 3x plus 2. Move your x over, subtract it from both sides. Move your 5 over, subtract it from both sides. This is going to give you x squared plus 2x minus 3 is equal to 0. This one factors out because your negative 3 has factors of negative 1 and positive 3 that add up to be positive 2. So this factors to give you x minus 1 times x plus 3 is equal to 0. Set them both equal to 0 and solve them. For the x minus 1 is equal to 0, add your 1 over. You have that x is equal to 1. For the x plus 3 is equal to 0, subtract your 3 over. You have that x is equal to negative 3. Your last part of your review goes over solving equations using absolute value. So for this example, for number 10, you have the absolute value of 3x plus 2 is equal to 7. For this one, double check, make sure your absolute value is by itself and it's equal to a positive number. It is in both cases, so we're going to separate this to be 3x plus 2 is equal to 7, as well as 3x plus 2 is equal to negative 7. we're just going to solve both of them. So with the 1 on the left, move your 2 over by subtracting it from both sides. You get 3x is equal to 5. Then divide each side by the 3, and you get that x is 5 over 3. For the 1 on the right, move your 2 over by subtracting it. You get 3x is equal to negative 9. Then divide each side by the 3, and you have that x is negative 3. For 11, you have the absolute value of 2x plus 5 is equal to 11. Your absolute value is isolated, is equal to a positive number. So separate this into 2x plus 5 is equal to 11. And 2x plus 5 is equal to negative 11. Move your 5 over, subtract it from both sides. With the 1 on the left, you're going to have 2x is equal to 6. From there, divide each side by the 2, and you have that x is 3. For the 1 on the right, you're going to have 2x is equal to negative 16. Divide that by 2, and you have that x is equal to negative 8. For number 12, you have 2 minus 4 times the absolute value of negative 3x plus 1 plus 7 is equal to 21. For this one, we're going to start by moving the 7 over, so we're going to subtract it from both sides. This is going to give you 2 minus 4 times the absolute value of negative 3x plus 1 is equal to 14. From here, we're moving the 2 over as well, so we'll subtract it. That'll give you negative 4 times the absolute value of negative 3x plus 1 is equal to 12. With this, lastly, to isolate the absolute value, we're going to move the 4 over, so we'll divide each side by negative 4. That'll leave us with the absolute value of negative 3x plus 1 is equal to negative 3. Your absolute value is isolated. However, this is equal to a negative number, which is not possible. So this one's just automatically no solution from here. For 13, we have the absolute value of 7x plus 11 is equal to the absolute value of 4x minus 20. There's no way to isolate the absolute value on this one, so we're going to turn this into 2 equations by number 1, keeping everything the same, but the absolute value is eliminated. And then the second one, you're going to keep everything the same, but isolate or get rid of the absolute value and also distribute a negative into the right side. So you're going to have 7x plus 11 is equal to the opposite of 4x minus 20. So if we solve the one that's on the right, we're going to move the 4x over first by subtracting it from both sides. So that's 3x plus 11 is equal to negative 20. Then move your 11 over by subtracting it from both sides, and that's 3x is equal to negative 31. Divide each side by the 3, and you get that x is negative 31 over 3. For the one on the right, distribute your negative on the right side. You get 7x plus 11 is equal to negative 4x plus 20. From there, I'm going to move the 4x over by adding it to both sides. So that's going to give us 11x plus 11 is equal to 20. We're going to subtract the 11 from both sides, and that's 11x is equal to 9. Then divide each side by the 11, and you have that x is 9 over 11.